Just hold on. Yeah. So the recording has begun. Let's resume our discussion. Um, so now we will study what happens. Very simple. If we have an air capacitor, how would the capacitance of this parallel plate capacitor look like if we put nothing but that is there's air between the two plates. So capacitance would simply be epsilon 0 d by d. Now instead of epsilon we are using epsilon 0. No big deal. And if there's a dielectric it would be epsilon. Now the interesting part is capacitor with a composite dielectric medium. Can someone tell me what this thing can be? This case? What does the name suggest? What it can be?
Sir,
Yeah.
so in the air capacitor, no, sir,
Hmm.
you wrote like C is equals to epsilon naught d by v, no, sir.
Sorry, sorry. It's, oh, yeah. No, it's fine. I think it's okay now. Now,
Yes, sir.
Acha. What about this thing? What this thing probably can be?
Maybe a more
Different permittivities. So
conductive.
Yeah, kind of that. That is, we may have medium with different permittivity. Hmm. So the picture would be like this. X equal to 0 is say one plate. X equal to d1. That means at d1 distance from 0 to d1, in this gap I have uh, a material of permittivity say epsilon 1 and call this region say region 1. This plate had positive sigma like we assumed before, and from d1 to d2, that is the total distance from here would be d1 plus d2, this being d2. I have another material whose permittivity is epsilon 2. Let me call this region 2, and this plate has negative sigma. Okay, so now you can see there's a partition kind of thing, isn't it? There are two different blocks of dielectric media. So what about the intensities? So what about the field intensity? in region 1 will be E1 equal to sigma by epsilon 1. So, and yeah, this thing is parallel. It's placed parallelly, okay? Else we couldn't have been able to write like this. And the field intensity in the second region would be this. I think everyone is okay with this thing.
So
Hmm. So again, let's try to compute the potential difference between the plates. Now I can call plate instead of conductor because these are actually plates. So that is V phi 1 minus phi 2. So that would be the first limit
Sir,
T2. Yeah,
so in the field intensity, sir, of region 2, we are only taking the magnitude, sir.
here.
Or do we only take the, do we also take the negative sign, sir?
Where?
Sir, yes, sir, out there, sir. Like, you wrote like of the minus sigma, no, sir.
Oh, yeah, we take the magnitude.
Oh, okay, sir.
We take the magnitude, and that is taken care of by choosing the limits. Okay, that thing has been taken care by that. I mean, at the end of the day, result would be same if I do it like this. Because if you take minus sigma plus sigma, again you do this minus sign plus sign, then things would be clumsy. Okay. That sign was to show the direction of the field. Okay, because see, you have sigma, you have minus sigma, and minus sigma is nothing but sigma with a negative sign only. So not much difference. So just before we saw the result of the integration, this would come as d1 plus d2 minus d1, and this would come as epsilon by sigma by epsilon 0 d1. So ultimately it would be epsilon d2 plus sigma by epsilon. Sorry. This would be epsilon 2 epsilon 1. Okay, try to find it yourself and check whether it is correct or not with what I got. Did you get
so
this thing?
it's minus in the E1, sir.
Here.
Yes, sir. For E1, so like E1 is for 5 1, no, sir.
Hmm.
So then, oh, you change the limit, sir.
Right. Limit has been changed. Is it okay?
Then it should be
Arranging, is it fine?
0 to D1, no? So then if limit is changed, so then or it's okay, sir.
Is it fine? I mean, are you convinced or you still have any problem? Any doubt?
So in the limit sign, so if it is changed sign, then it should be 0 to D1. No, sir.
Yeah, 0 to d1. In original it was 0 to d1. Okay, and then due to this minus, again minus came. Is it okay, Arinjali? Okay, fine. So next thing you all know, you have to express sigma in terms of the charge. So the potential difference would look like sigma means d1 plus q by a 2 by epsilon 2. So capacitance is nothing but q by p. So from here you can get q by p means a by this, a by this thing, 2 by epsilon. Okay, now we know that epsilon 1 can be written as k1 epsilon 0 in terms of dielectric constant of that medium, where this k stand for the dielectric constants. Isn't it? Remember that formula? Because in the exam, in the question, you may be provided with the dielectric constant instead of permittivity. Okay, there is another reason to do this. If I put these things here, then ultimately I would be getting something like this. See, now it looks kind of the capacitance of a parallel plate capacitor, epsilon naught a by d kind of thing. This thing has the dimension of length only. Why? Because k1 and k2 are dimensionless quantities. Okay,
So
so if we have many such different kind of dielectric medium, so in general we can write that C equal to epsilon 0 a by sum over I di by ki. Say 4. So d1 by k1 plus d2 by k2 plus d3 by k3 plus d4 by k4. Like this, we can write this expression for any number of, I mean, for any case of composite dielectric medium. Okay,
so
fine. Now another special case here. Special case of air capacitor. It's not purely air capacitor. Why? We'll see. Suppose I have a air capacitor. Displayed sigma plus sigma minus. Separation is D. Okay, and inside it I have a dielectric slab. Not throughout, but only in this region. I have a dielectric slab whose thickness is small t. Okay, this is what we have, and rest of the portion is filled with air. So it's needless to say that T is less than D. Fine.
Yes, sir.
So how can we find this out? We can modify the expression of the potential difference, because that was the first time where this difference terms came up, isn't it? So we can do it like this. Can do it like this. So the potential difference between the plates. So we have to take into account two things: air and dielectric. So the dielectric medium has, say, permittivity epsilon, and for air, you know, it is epsilon 0. So field would be same. Field would look same. Why? Because they are placed parallelly. This thing has been placed parallelly. So this potential difference would be sigma by epsilon. What is the thickness of the dielectric? T. And for air, sigma by epsilon 0, and the remaining portion from D is filled with air. See if you could understand or not this part. I'm getting a lot of mails since morning because your first years have to send me a lot of things. Okay, today is the deadline. Anyways, that's why my phone is getting some.
Got it, sir.
So, guys, I think Sir's network went off. Let's wait for a while, okay?
Okay. Shravan,
Ah,
oh, ini kan sudah sila sila bagaimana?
question much uni bro. Oh,
Ini
record
kosong
witness on the chat record witness. Bro.
Sorry, I got dropped off. Acha. So that's how the potential would look like. Now again, the same old thing, replace the value of sigma in terms of charge. Okay, I think it would look something like this. So what about the capacitance? The capacitance would look like this. Again, we can replace epsilon in terms of epsilon. We can write epsilon in terms of epsilon 0. Yes, Shravan, I got disconnected. I got a call from Priyam suddenly. And once you get a call on the phone, whether you receive or not, you'll be disconnected from Google Meet. So that's why I got disconnected momentarily. Anyways, so I can take this epsilon above. So capacitance ultimately would look like this. Okay. But this thing you can get from this formula as well. Okay, same thing. From that formula also you may get. In the exam, the question sometimes may come like that. Find the expression for a composite dielectric. Hence, you would be given this special case and you'd be asked to calculate the uh, expression for this case. Is it okay?
Yes, so
Okay, fine. Achha. So now definitely something is coming to your mind that will always the dielectric put in this beautiful manner so that it is symmetric, so that it is in a manner uniform. Okay, it may not be so. So the general case would be a more general case would be the capacitor with a non-uniform dielectric inside it. Let's see how it would go. So let's check out this thing. The capacitor with a non-uniform dielectric. I mean, the capacitor is obviously the parallel plate capacitor. I think this thing was there in your class 11. I think little bit was there. I don't know. Maybe you have forgotten. So I'm just drawing it. It may be like this. Why? What if I have a parallel plate capacitor and the distribution is like this? Say in this portion I have a dielectric of epsilon 1 permittivity. Here I have another dielectric of epsilon 2 permittivity. But they are not placed parallelly. The distribution is not uniform. Okay, but it is non-uniform. Is it clear?
the distribution of the fields of
Yeah. Uniform distribution means like this. Just the things that we were studying previously. This is like one, this is another one. This is uniform distribution of dielectric, okay? But here it is not uniform. Okay, so mm, This can be one case. Okay. Another thing can be if your capacitance changes, if your sorry, uh, if your dielectric constant varies with distance. Okay, that can also be another thing. You may think that this part is air. Okay, and the remaining portion that has been kept, its dielectric constant changes with distance. Okay, this is also one situation, but here we'll study a case when the dielectric constant varies with distance. Okay, this kind of thing also is there. That's not in our syllabus right now. Okay, so what is the thing? I have a parallel plate capacitor, but the material within inside it is permittivity or dielectric constant varies with the distance from one plate to another. Say let the dielectric constant at any point, say P. Here is a point P, which is at the distance x from the first plate, looks like k equal to alpha x plus beta, where alpha and beta are constants. So can you see that as x changes, the dielectric constant changes?
Yes, sir.
Okay, so this is a non-uniform dielectric constant case. Fine. So now what we can find, say now at x equal to 0, that is at the first plate, plate 1, plate 2, value of k is k1, and at this plate, if this distance is d, the gap between the two plates, then at say at x equal to d, that is on the second plate, permittivity is k2. Put these values here and let us try to find alpha and beta. So therefore k1 is equal to x is 0, so k1 is equal to beta. There, so the equation now becomes k equal to alpha x plus k1, and at x equal to d, k is equal to k2. Also at x equals to d, k is equal to k2. So what is the value of alpha? Alpha is equals to, sorry, it is k1, k2 minus k1 by t. So these are the two values of alpha, the values of alpha and beta. Hence our capacitance at any point looks like this. Okay.
So is your camera off, sir?
Now is it?
Oh,
Acha.
yes, sir. It's visible.
Hmm.
So that's
Acha,
K1 also.
yes, it's
That's
K1,
K1
no?
also.
K1, K1, yeah. Acha, have you been informed that you have to collect the answer script for this exam from college? You know that?
Yes, sir.
Acha, from 10 to 1 p.m. I think you know, na?
So, like, when do we have to come, sir? Like, you can come any
I
at
mean,
any time, sir. Like any like specific date, sir.
Acha, from where did you get this news?
So, like the one PDF was given, sir, from there out there, sir.
Acha, your friends have you have circulated it amongst yourself, right?
Yeah, so I don't know, sir. I got it from a other source, sir, like from a person from a different college.
Oh, acha.
But the
So,
main news has been circulated from our college, sir. Like no one has circulated it.
hmm. So I thought that you know that thing because maybe the CRs have been given that thing. I think you have to go before this puja vacation. Okay, this is Diwali. You can do one thing. You
So
can
like
call
they
someone
haven't
in
said,
the college.
oh, okay. So like because like they haven't given any like information to us. So in the CR group also like they haven't said anything, sir.
Acha, acha.
So any date, specific date, so that we should go
No, no.
on that date.
Right now I'm getting this thing that today also was the date. I don't know. I also didn't get any news in that regard. I don't know what happened. Okay, we'll talk about that after this class. Let me finish this topic, then we'll discuss. Don't worry. Anyways, so that's how the capacitance looks like. That means the capacitance at the plate 1 is K1 and the plate 2 is K2. X equals to D, X equal to 0. Fine. So now I can write the electric field expression. So at P, electric field would look like sigma by epsilon. That is sigma by epsilon 0 K. See, there is only one material inside. Okay, there are no composite materials inside. But that material has different permittivity at different distances. So put the value K2 minus K1 by dx plus K1. Okay. Therefore, the potential difference between the plates is E dx, not E dot dx, no matter, no problem. E dx and E dot dx, x and E are along the same direction. They're parallel from plate 2 to plate 1. Put the value as E1. So if you remember the formula, dx of uh, sorry, integration dx by ax is equals to 1 by a ln x by a. That is the formula. So here a is what? This thing, the coefficient of x. So the result would come like this. The limit is from d to 0. And if we put the value of sigma, we would get something like this. Okay, so what would be the capacitance? Very, very important conclusion. Okay, if someone gives me,
So one,
yes,
so one, can you show the previous page, sir?
this treatment can be done no matter what the distribution of, I mean, how the dielectric behaves. If it looks like, if it had looked like this, then also you can do same procedure. The main thing will come in the integration. That is where the main challenge will come.
Thank you, sir.
Okay, so that is the main expression. So very important.
Sure, sir.